Hello and welcome again to my channel. In this video, we are going to solve what is called a Legendre linear differential equation. Well, in this differential equation, as you can see, the coefficients of the second order derivative term and the first order derivative term are non-constants or they are variables. Now, this is a Legendre linear differential equation because the coefficient of y double dash and y dash are kind of related to each other. So as you can see, the coefficient of y double dash is of the form ax plus b whole squared, whereas the coefficient of y dash is ax plus b. It's in the form of ax plus b. And if you compare ax plus b with 2x minus 1, we shall be getting a as equal to 2. Well, you see, we can really ignore the value of b for our computations over here. All right. Now, on the right hand side, we have got 8x squared minus 2x plus 3. So what we'll do in the beginning is that we will try to write this in form of 2x minus 1. So you see that 8x squared plus 8x squared minus twice x plus 3 can be written as well, the first term is 8x squared, right? So we can write that as 2 multiplied by uh, 2 multiplied by 4x squared, right? Now 4x squared can be written as 4x squared minus 4x plus 1 plus 4x minus 1, right? So all of these things, let's put them in a bracket, then minus 2x plus 3. Okay, now here we, if you look carefully, the terms represented by 4x squared minus 4x plus 1 is same as 2x minus 1 whole squared, right? And the rest of the term, if we open the bracket, it becomes plus 8x minus 2 minus 2x plus 3. So we get this as 2 times 2x minus 1 whole square plus 6x plus 1. Now 2 times 2x minus 1 whole square remains as it is, and if you look carefully at this 6x, this can be written as 3 times 2x, right? So let's write the 2x as 2x minus 1 plus 1, right? And then plus 1 at the end as it is in the previous step. So we can write this here as 2 times 2x minus 1 whole square plus 3 times, well, this 2x minus 1, maybe we'll just use the red ink to represent that, and then plus 3 plus 1, and that will give us 2 times 2x minus 1 whole square plus 3 times 2x minus 1 plus 4. So what we have done here is we have simplified, we have rewritten our 8x square minus 2x plus 3, whichever the term on the right hand side, in terms of our 2x minus 1, which is essentially uh, the ax plus b term. Okay, now substituting those values, we can rewrite our given differential equation, a Legendre differential equation, as 2x minus 1 whole square y double dash. Let's see. Okay, that is plus 2x minus 1 y dash, and then minus 2 times y as equal to 2 times 2x minus 1 whole square plus 3 times 2x minus 1 plus 4. Now, now the viewer might be asking us, why have we done that? This is because we are going to use the method of substitution, and we are going to substitute 2x minus 1 as e raised to the power t, right? Okay, now that is the first kind of substitution. The second kind of substitution is 2x minus 1. See, we are converting our equation in such a way that the independent variable becomes t. You know, it was x in the beginning. We are converting that to t, and 2x minus 1 y dash is going to be equal to dy, where again, you see, this d is d by dt. right? So this is the differential operator with respect to t. And also 2x minus 1 whole square y double dash is going to be substituted as a squared times d minus 1 times y. Now you remember that the value of a was equal to 2, right? And this gives us the privilege of writing this as 4d square minus 4d of y. Now, after this substitution, our equation becomes our equation becomes 4d squared minus 4d of y plus dy minus 2 times y is equal to 2 times e raised to the power t whole square plus 3 times e raised to the power t plus 4. And if we simplify the left hand side, we shall get 4d squared minus 4d plus d minus 2 of y, and the right hand side will become 2 e raised to the power 2t plus 3 e raised to the power t plus 4, right? And a further simplification will give us 4d square minus 3d minus 2 of y as equal to 2 times e raised to the power 2t plus 3 e raised to the power t plus 4. Okay, now what we do here is as follows. Okay, so we will of course, like in order to solve this equation, we'll first find out what is the complementary function, and then we'll find out what is the principal integral, the particular integral, pardon me. Okay, so in order to find out the complementary function, what we do is we will write down the auxiliary equation. It is 4d squared minus 3d minus 2 is equal to 0. And as you can see that the middle term factorization here is not possible. So we shall write d as equal to negative of b, that is negative of negative 3 plus minus square root of negative 3 whole square b square minus 4 times a is 4 and c is negative 2 divided by 2 times 2 times a, that is 4, right? Okay, so that gives us 3 plus minus square root of 9 minus 9 plus, right? Minus and minus become plus. 16 multiplied by 2 is 32. Yes, so that divided by 8, and that gives us 3 plus minus square root of 41 by 8, right? And from here we shall get the two roots as m1 is equal to 3 plus square root of 41 divided by 8, and m2 as equal to 3 minus square root of 41 divided by 8. And you notice that both of these roots are real, right? They're real and distinct, real and unequal. So therefore, what we can do here is we shall write down the complementary function as C1 e raised to the power m1x, so that is 3 plus square root of 41 divided by 8 times x, right? And plus C2 e raised to the power m2x. So what is m2? M2 is 3 minus square root of 41 divided by 8 times x. So this is our expression 1, right? We can save this for the use later. Before we proceed, there is a little error over here. Our independent variable is t, so we should mention t over here. This is not x, that is t. Okay. Now, in order to find out the pi, right? So the pi, y pi is going to be equal to the right hand side of the equation, which is 2 e raised to the power 2t plus 3 e raised to the power t plus 4 divided by 4d square minus 3d minus 2. Okay, now this equation, this particular integral can be written as follows. So it is 2 times e power 2t divided by fd, right? That's the shorthand for the entire denominator, and 3 times e power t divided by fd, again that is the short form for the entire denominator, plus 4 times, well, 1 can be written as e power 0 multiplied by t divided by f of d. Okay, so great. Now we are done with this. So what we'll do here is we will independently find out each of these terms and we will substitute them in the ypi, correct? Okay, so e power 2t, so let me use a different color pen over here. So e power 2t divided by fd, which is 4 multiplied d square minus 3d minus 2. So we'll try to find out this. So you see here that the value of a is equal to 2. And once we substitute the value of a as equal to 2 in the denominator, what do we get? We get 4 times 2 squared minus 3 times 2 minus 2, which is equal to, well, 4 multiplied by 4 is 16. 16 minus 6 is 10. 10 minus 2 is 8, which is not equal to 0. So what we get here is as follows. We obtain e power 2t divided by f of d as equal to e power 2t divided by 8, right? Okay. Then we'll move on and find out what is e power t divided by fd, right? So e power t divided by 4d squared minus 3d plus minus 2, right, minus 2, and here a is equal to 1, and again we'll substitute a is equal to 1 in the denominator. See what we get. 4 multiply 1 squared minus 3 times 1 minus 2, right? So 4 multiply 1 is 4, 4 minus 3 is 1, 1 minus 2 is negative 1, and that is not equal to 0. So we can proceed with writing the principal, the particular integral et divided by fd as equal to e raised to the power t divided by negative 1. Now for the last term, what we do is exactly same as what we had done previously. So e power 0t divided by 4d square minus 3d minus 2. So here the value of a is equal to 0. And let's find out whether the f of a is equal to 0 or not. So 4 multiplied by 0 square minus 3 times 0 minus 2, that is equal to 4 times 0 is 0 minus 2. So it is negative 2, which is not equal to 0. And that tells us that e to the power 0t divided by fd is equal to e power 0t divided by negative 2. Okay, so now we are nearly done with this particular problem. So you see ypi was a linear combination of 2 times the first principal integral plus 3 times the second principal integral plus 4 times the last principal integral, the particular integral, my bad. So ypi, we get ypi as equal to 3 times the first one, right? Oh, oops, that's my mistake. So it's 2 times the first one. So 2 times the first one is 2 times e power 2t divided by 8. Then we have got it plus 3 times e power t, right? So 3 times e power t divided by negative 1, and then plus what is that, 4 times, right? So yeah, 4 times the last one, so plus 4 times e power 0 times 0t divided by negative 2. Now if we simplify this, we shall get 1 by 4 e power t whole square, right, plus well, not plus, we can do minus 3 e power t, and then we can do minus 2. So that is our ypi. Let's label this as the second expression. Okay, let's return to the first expression and let's try to make a few changes over there, right? So let's see how we can do the change. So so what we do here is we can write this as c1 and e power t whole power 3 plus square root of 41 divided by 8 plus c2 e power t whole to the power 3 plus square root of 41 divided by 8. Okay, so that's not plus, that's minus over there. All right, so we have got this expression as the first expression. We have got the second expression. Now it's time that we combine both of them, right? Okay, now So what we get is y as equal to ycf plus ypi. That is the general solution, right? That's the answer that we are supposed to look at. So that is c1 et to the power 3 plus square root of 41 divided by 8 plus c2 et whole to the power 3 minus square root of 41 divided by 8 plus 1 by 4 e power t whole square minus 3 times e power t minus 2. Okay, now we know that e power t is 2x minus 1, right? So what we do is that we substitute the value of e power t as 2x minus 1, and let's see what answer we get. So we shall get, therefore, y, which is a solution, that would be c1 times 2x minus 1 raised to the power 3 plus square root of 41 by 8 plus c2 multiplied by 2x minus 1 whole to the power 3 minus square root of 41 by 8 plus 1 by 4 twice x minus 1 whole square minus 3 times twice x minus 1 and then minus 2, right? So that, my friends, is our answer. What we can do is we can basically, further simplify this last bracket and take out the minus 3, so it becomes minus 6x minus 5. But I think this, and also you can open the bracket out over there, and we can simplify that a little bit further, but this remains the answer. All right. Thank you so much for watching the video. Bye.